Hi future doctors, welcome to the next class. In this class we will see angle of contact and capillarity. So what is the capillary rise or fall and angle of contact? Angle of contact not visible. Angle of contact and capillarity. So if you have seen any liquid in a vessel, so this is a vessel. If you pour some amount of liquid, sometimes it may be coming like this. Next, this is a vessel. If you pour liquid, it may come like this. So this is a vessel. If you're taking liquid, it may be coming like this. The shape of the liquid surface is coming in different ways. This is convex if you are viewing from here, concave, this is plane surface. Okay, so this shape we will call meniscus. What is the shape of the meniscus will be depending on angle of contact. How we will define angle of contact, why it is coming in this particular shape, we will see. So this is the liquid inside, this white color entire thing. If you are taking one liquid molecule here, so this is a vessel. So this is the vessel. So vessel molecule, liquid molecule. Two different types of molecules are there means between those two molecules adhesive force is going to take place. So if you are taking Feviquick, on the Feviquick they will write the force of adhesion they will write. So the liquid will provide attractive force between two different molecules or two different objects. Next, this is water molecule. If you are taking water here, so between these two, you will be having cohesive force. During surface tension, we use this word. Cohesive force means the force of attraction between two same molecules. Adhesive force means the force of attraction between two different molecules, vessel and liquid and liquid, vessel molecule. We have cohesive force like this. So this attractive force is going to be less. In which case, meniscus convex shape. Here attractive force is going to be more between liquid molecule and vessel molecule. Therefore, shape of the meniscus will be coming like this. Now, what is the definition for angle of contact means? The tangent drawn. Tangent you should not draw here. Here. So where you have to draw tangent means you have to draw the tangent at a point of contact between liquid and vessel here. So how much angle it is making this tangent inside the liquid? This is nothing but angle of contact. If you want to draw tangent here, it will be coming like this. This is nothing but angle of contact. So here it is going to touch the liquid surface. If you have drawn tangent, this is the angle of contact. Angle of contact here it is going to be 90 degrees. Here it should be greater than 90. Here it is less than 90. So in mathematics they will say acute, obtuse angle. So greater than 90 means shape of the meniscus is going to be convex. Less than 90 means shape of the meniscus is concave. So for this type of liquid, so you will be having wetting nature more. This is not wetting nature. No wetting is going to be happening. So for these two types of liquids, you will be having capillarity. So what is capillarity means? The rise or fall of liquid. The rise or fall of liquid in capillary tube. What is capillary tube means? The tube which is having very fine bore. By fine bore means very small radius of cross sectional area it is going to be happening like our hair. Hair is how much thin? Like that. In pen refill will be there. That refill will be having capillary tube. If we use this wetting nature, where we are going to use not wetting nature. So if you are taking normal cloth means during rain it is going to become wet because angle of contact between water cloth is going to be less than 90. But if you use raincoat, in raincoat, which material they are going to use means, so which is having angle of contact greater than 90 degrees. If you are taking water in your hand, it is going to wet. Means hand is going to become wet. It is having wetting nature. But if you are taking mercury, it cannot wet. So because mercury is having angle of contact greater than 90 degrees. So if you increase the temperature of water, angle of contact decreases, surface tension decreases. Therefore, wetting nature is going to increase. So in olden days, they used to wash the cloths by using hot water because this is the reason. So whenever you are making hot, its angle of contact will decrease, surface tension will decrease. It is going into the depth of that cloth and it is going to clean. Nowadays, we are using detergents. Why we have to use detergents means to decrease the angle of contact. Surfacial aerial we will use detergents. Those detergents we are using because of decreasing the angle of contact and to wash the cloths very cleanly. So these are the theoretical questions they are going to ask. Now because of this, depending on this angle of contact, so the rise or fall of liquid may happen. So within this, if we are taking one fine capillary tube which is having fine bore, so the shape of the meniscus which is having less than 90 degrees, it is going to rise. It is going to rise upwards liquid within the capillary tube. So theta here less than 90 degrees. If you are taking another vessel, so which is having angle of contact greater than 90 degrees, so it is going to fall. So this fall or this rise of liquid within the capillary tube whenever it is going to be immersed. This concept is nothing but capillarity. Theta is greater than 90, less than 90, it will rise. Theta is greater than 90 degrees, it is going to fall. How it is going to be rising? So if we are taking one capillary tube like this, so on this one shape of the meniscus we are taking, how it is going to rise means here at this point of contact we are drawing tangent. This is going to be theta, this is also theta, this is going to be surface tension T. Here also you can take this is theta, theta, surface. So if you resolve this one into two components, this is going to be T cos theta, this is T sin theta, T cos theta, this is T sin theta. So in upward direction, how much force tensional force means surface tensional force is acting means T cos theta. T cos theta is acting in upward direction on how much length means, so shape of the meniscus is having r radius means on how much length it is going to act in upward direction means force acting on length 2 pi r. Therefore, F is equal to 2 pi r into T cos theta. So, why it is rising means some amount of force acting on the liquid meniscus and it is bringing like this. So, if it is the liquid surface means it is holding and it is bringing like this. So, how much force is acting means this much 2 pi r T cos theta. So, up to where it is going to bring upwards means weight of this liquid within this capillary tube should be equal. That is going to be mg. This formula is going to be important. At equilibrium condition, 2 pi r T cos theta is going to be equal to mg. How much height it is going to rise? I am not giving derivation, directly I am giving formula. That is going to be HR dz by 2 cos theta. Here T is surface tension, H is how much height it is rising or falling, R is radius of this capillary tube, D is density of this liquid, G is acceleration due to gravity. The rise or fall will be depending on these many physical quantities. So 2T cos theta by R dG. So if you are taking different capillary tubes for the same liquid, then how much height it is rising? HR is constant. So same capillary tube at two different places, then Hg is constant. They are taking into space, they will ask. In space, G is going to be 0. So with two different liquids, same capillary tube or different capillary tube, RD equal to constant. So mainly they will ask either this formula or on that Hg equal to constant. So let us assume if you are taking same apparatus into the space, how much height it is going to rise there. So length of this capillary tube is 20 centimeters. So if you are taking into space, how much height it is going to rise, they will ask. Here h is inversely proportional to g. G is 0 means h is infinity. Infinity means it is going to occupy total length. It will not overflow. So total height is going to be maximum 20 centimeters you have to take, because in space g is going to be 0. Don't take h is going to be infinity. They will mention length of that capillary tube. And from this formula we will write h1r1 equal to h1r1 equal to h2r2. So like this, different radius of capillary tube, different heights it is going to be rising. Next, if they make with different angle of contact or with a different angle of immersion, means, so you are going to immerse like this, then liquid is rising up to h height. Now we are making with some angle, elevation or angle. So capillary tube is making some amount of angle alpha. Then how much height it is going to be rising? Height remains always same. Length of this column they will give. So length of this column is going to be L they will give. At the time how they will write means H is always going to be remains same. Therefore, this L if you resolve into two components. So see here, this is alpha L. Then if you resolve two components, this is going to be L cos alpha, this is going to be L sin alpha, isn't it? So depending on this H and which angle they are going to give, so we are going to equate that, isn't it? So like this you can take L cos theta if they are giving, means L cos alpha is horizontal component. So L sin alpha is going to be vertical component. So if H is only making angle, height, if they give height is going to make some angle, then H cos alpha, H sin alpha, isn't it? Here you have to see with which they are giving this angle. Sometimes they will give angle, this is capillary tube, so another capillary tube, they will give this is going to be theta. Then height remains same, but they will give length of this liquid. At the time, this is going to be L cos theta. L cos theta. So angle with which they are giving, you have to see very clearly. Depending on that, you have to rearrange. This is L cos alpha. We don't want this. We want L sin alpha. Height we are going to equate, isn't it? So like this, you have to take whenever they are giving capillarity question. So if H are equal to constant from this equation, then H is inversely proportional to R. Nature of the graph, H and R. What you will get? Rectangular hyperbola. So H and 1 by R graph they will ask. H and 1 by R is going to be directly proportional. Therefore, you will be getting graph like this. So you have to use on different cases whenever they have given different radius of capillary tubes, it should rise different heights. Same liquid, density is going to be same, surface tension is going to be same place. If different place means, we will take G also within this equation. Therefore, whichever different, whichever same, they are asking, with angle they are asking, how much force is going to act. Sometimes they will ask what is the potential energy. Potential energy means U is equal to mgh. Mg is going to be this much, that is 2 pi r t cos theta. H is nothing but this equation we are going to use, that is the potential energy. Next we will see in this how they are going to ask the questions. Later we will see, this is the concept we have given. Thank you.